So in the last video we have discussed how your soil is formed. Okay, you have learned that from any rock, due to the weathering effect, your rock disintegrate and you form soil particle like this. Okay, but in actual condition this soil particle cannot exist alone. Why? Let's say these soil particles are staying in an environment, and obviously there will be some air, so these voids are filled with some amount of air like this. Let's say these are air bubble. Okay, and also if there is rain like this, they fill the void here with water droplet. Okay, so if we consider the soil in overall or globally, a soil consists a solid, a liquid or water, and your air. So there are three phases which is existing in your soil. Now let's express these three: solid, liquid and air by a diagram. Okay, let's say this is the system of soil, and let's consider this is as solid or the fragment of rock. Okay, and the volume of this solid is, let's say, Ps, and weight is, let's say, Ws. Okay, now there are liquid. Let's consider this is the liquid part. Okay, so this is the liquid part or water, and the volume of this water is, let's say, volume Vw, and weight of this water is Ww. Okay, and the remaining part is air, and we will not consider the weight of air. It is negligible, but this air has some volume. So let's say the volume of the air is Va. Okay, so this is your air, this is your water, and this is solid. Okay, and based on this proportion of air, water and solid, there are different properties of soil which define your strength or your permeability or consolidation characteristics like this. Okay, so that's why whenever you are collecting your soil sample, it is very much important you define or you quantify all these parameters. Okay, that is how much water is available within the sample, or what is the weight of solid particle only. So for that we need to learn the phase relationship, Okay, and in this diagram you can see that for this soil, this is the overall soil, there are some volume parameter and weight parameter. Based on the volume parameter, you can define phase relation based on volume. Okay, so based on volume you define some phase relation, and based on your weight you define some another group of phase relation. So let's start with volume. Okay, let's say this is the volume of air and volume of water, or we can say this is volume of void. Why? Let's consider again a soil system. Okay, but in this soil system you have only solid, you don't have any water. Here is air, so it is a completely dry state. So in this dry state, this three-phase system become two-phase system. Also consider another system. Let's say this is another system, and this is your solid. Okay, and the remaining part is completely filled with water. There is no air, so this is water and this is your solid. Again, this three-phase system has become two-phase system for this completely saturated soil. Okay, so this is the saturated soil and this is the dry soil. In both cases, this three-phase system has been reduced to two-phase system. Okay, so let's consider again, this is your soil system. Let's say this is the soil, okay, and this is the solid particle, this is solid soil, and the volume is Vs, weight is Ws, this is your water, okay, the weight of water is Ww, volume is Vw, and this is air, the volume is, let's say this is V air, and combining the volume of air and volume of water, you can say this is volume of void. Okay, in this soil system, these are actually voids, and these are represented by this volume of void. Okay, so first we will discuss what is the volume relationship. This is volume relationship. The very first relation is known as void ratio. Okay, or you can express it by E, small e. And what is void ratio? By definition, this is the ratio between void, that is volume of void, this one, divided by the volume of solid, that is Vs. Okay, so this is known as void ratio and it is expressed in decimal. Okay, so now let's say in such a system where the volume of void, let's say this is a system of soil, here volume of solid is half and volume of void is half. Okay, so in this case your void ratio become 1. Okay, so this is our very first volume relation. Let's move forward to the second relation. What is the second relation? The second relation is known as porosity. So what is the definition of porosity or N? Porosity or N is expressed as the ratio and multiplied with 100. So what is the ratio? The ratio is the volume of void, that is volume of void Vv, to the total volume. So what is the total volume here? Total volume is volume of void plus volume of solid. So this is total volume from this point to this point. This is total volume V. And porosity is always expressed in percentage. That's why I have multiplied here 100. Okay, so this is porosity. Now obviously porosity as well as void ratio both are related to volume, so obviously there will be some interrelation between this void ratio and porosity. What is that? Let's find. So N is volume of void by volume of total volume. So total volume is volume of void plus volume of solid. Now divide top and bottom with Vs. Vv by Vs divided by 1 plus Vs, Vv by Vs plus Vs by Vs. What you are getting? Vv by Vs is void ratio. So E divided by, again this is void ratio, plus Vs cancelled, so 1. So here you can see that porosity and void ratio is connected to each other by this relation. This is our third phase relation, that is N is equal to E divided by 1 plus E. or you can express it like n plus ne is equal to E, or your E1 minus n is equal to n, or E is equal to n divided by 1 minus n. In either way, you can express the interrelation between the porosity and void ratio. Okay, so what is the next? The next is degree of saturation. So the fourth is degree of saturation. Well, what is degree of saturation? Here you can see the total void is this much. Okay, so this is the total void. Sorry, yes, this is the total void, and this void either can be filled with water completely or partially. Okay, so here you have seen that in case of a dry state, this volume of void is completely filled with air, there is no water. But in case of complete saturation, there is no air, only water. So we can define this degree of saturation by this quantity of water or volume of water VW to the ratio of total volume, that is total void, that is VV. Okay, so degree of saturation DOS is volume of water to the volume of void. So when this is completely filled with water, we can say that this volume of water is equal to volume of void, or it becomes 1. So in this case, the degree of saturation is 100%. Okay, so this was our fourth relation. Now what is the fifth relation? What is the remaining? Well, we have talked about total volume to the volume of void. Okay, that is your porosity. We have talked about volume of void to volume of solid, that is void ratio. We have talked about volume of water to the volume of void. So remaining one is your air. We have not made any relation with this air. So with this air, we can make the similar relation like degree of saturation. Here the term is air content. Okay, just like your degree of saturation define or quantify how much volume is filled with water, but air content define how much volume of void is filled with air. Okay, so what is the air content? Air content is your AC, that is volume of air to the volume of void. Okay, so that's all for your relations related to volume. Now go to the relations which can be defined from weight. For that, again draw the phase system, three-phase system of the soil. Let's say this is the solid of weight WS. Let's say this is the water with weight WW, and we neglect the air in case of weight. Okay, so total weight is this much, that is W. In case of volume, we have taken this is the total volume, but in case of what weight, we have taken this much because we neglect the weight of air is neglected. Clear? So what is the first relation related to your weight relation? So weight relation. First weight relation is your moisture content. Okay, here it was degree of saturation which relate water and void. Okay, and here this is moisture content. The first one is moisture content. So what is moisture content? Moisture content is defined with small w, that is the ratio of weight of water to the weight of solid. Okay, so weight of water to the weight of solid is known as your moisture content. Okay, so can you tell me what is the moisture content in case of a complete dry soil? Well, in case of a complete dry soil, the weight of water is 0. So the water content or moisture content small w is equal to 0. Clear? And it is not like that it varies from 0 to 100% when it is become equal to weight of solid. It can exceed 100%. It is quite natural that the weight of solid is less than weight of water. In that case, this W is greater than your 100. Okay, so this is our first weight relation. The next relation is your particle unit weight or specific gravity. Okay, so specific gravity, G is specific gravity, and this GS is completely related to your solid. Okay, so what is the specific gravity of your solid? Well, if I to discuss the specific gravity, we also need to associate a term, that is your particle unit weight or gamma. Okay, gamma of soil. So what is unit weight? Unit weight gamma is simply the, well, here unit weight is not bulk unit weight, this is particle unit weight. Okay, so that's mean, so what is the unit weight for particle or solid? Simply the weight divided by the volume. So what is the volume of solid? That is Bs. So unit weight is W is divided by Vs. Clear? And we can express this unit weight by gamma W. This is the unit weight of water, times specific gravity, Gs. Okay, so you can find Gs by this formula, W is divided by Vs divided by gamma W. Okay, by using this formula you can find the specific gravity of the solid particle or the soil particle, not overall specific gravity. Again I am saying this is related to the particular solid particle or only this one. Clear? Now the next thing is, or the third weight relation is your the dry unit weight. Okay, so what is the dry unit weight or gamma D? Gamma D is weight of solid particle to the total volume. Okay, and here you can see we have not concluded or we have not included weight of water. That's why it is called dry density. So density is simply the total weight by total volume. Here we have taken total volume, that is V, but in case of weight we have taken only weight of solid, Ws, because this is dry. That's why the water content Ww is simply 0. Okay, so this is dry density. So the dry density is gamma D. It was our third relation. Now come to fourth relation. While we have already talked about dry density, now talked about bulk density. Okay, so what is bulk density? Bulk density is the total overall density of this three-phase system, where your volume is V, or you can say this is volume of void plus volume of solid. This is the volume of void. This is volume of void, that is volume of water plus volume of air plus the volume of solid, which make your total volume. And at the numerator, the weight is weight of solid, weight of water, and weight of air, that is 0 as per our assumption. So bulk density is given by Ws, that is weight of solid, weight of water. From the name you can assume bulk means everything is included, and volume is total volume, okay, or volume of void plus volume of solid. This gives you the bulk density or gamma bulk. So these are the weight relations, okay, and previously we have discussed what are the volume relations. In three-phase system, soil system, these are the most important thing. That means you need to know what is volume relations and what is weight relations. Okay, just like you have seen in case of void ratio and porosity, they are interrelated. Similarly, these volume relations and these weight relations, they are also interrelated. Okay, let's see some example of this interrelation. The first is, you know that water content W. What is this? This is a weight relation, water content or moisture content W, that is defined by weight of water divided by weight of solid. Okay, so this is weight of water by weight of solid. Okay, now we can write this weight of water by this, that is unit weight of water, that is gamma W, into the volume of water. Okay, so weight is simply unit weight into volume. And similarly, we can write weight of solid as unit weight of solid particle, that is your this one, unit weight of solid particle, that is gamma W into GS. Okay, so this is become gamma W into GS, gamma W into GS times volume of solid, just like this one. Now cancel this, and again VW by VS. What is this? This is volume of water divided by volume of solid. What is this? Well, let's try to find if there is some relation in this. Is a volume related, so we will find something in volume relation. So what are the parameter? Volume of water and volume of solid. So water versus solid. Let's see, is there anything? This is volume of water by volume of void, and this is volume of void by volume of solid. Okay, let's pick up this one. So E is equal to your volume of void by volume of solid, but we need to know volume of water. Again, if this is the three-phase system, let's say this is your solid, so Vs, and this is total volume or volume of void. Okay, so it is not total volume, sorry, this is volume of void, and it comprises of some amount of water and air. Okay, this is water, let's say this is your Vw, and air, this one. So volume of water can be expressed with volume of V by this formula. Volume of water by volume of void is nothing but saturation. Okay, let's check in volume relation. Yes, volume of water, volume of void is degree of saturation, or S. Okay, so saturation, we have got saturation by this formula, and void ratio is by this formula. We need Vw. Well, so let's rewrite W, small w, by this formula, that is Vw. Vw can be write as VW is equal to S times VV. So this is coming as S times VV, and at the denominator this is GS and VS. Again, VV divided by VS is equal to your E. Okay, so S times E by GS. So you can write water content as ES by GS. Okay, so this is the most important interrelation. So you have seen how we have reached this interrelation. Just like this interrelation, you can derive many more interrelation. For example, we can write our bulk density or dry density gamma D. What was gamma D? Gamma D was simply, it was your, let's check in weight relation. Gamma D, where is gamma D? This is GS water content, and this is gamma D. Okay, this is gamma D. Gamma D is simply weight of solid by total volume. Okay, so weight of solid by total volume. Clear? And you can write weight of solid by this formula. This was our weight of solid formula. Here, weight of solid, this is also weight of solid, so gamma W times GS times VS by V. Okay, again we can write your P as gamma W GS VS. P can be write as volume of solid plus volume of void. Okay, this is the total volume, that is VS plus volume of void. Okay, and now if you divide both the numerator as well as the denominator by VV or volume of void, let's see what happened. It is coming as gamma W GS VS by your VS. We are dividing both by VS. Okay, so here VS by VS plus VV by VS, and this gives you 1, this also gives you 1, so you are getting gamma W GS divided by 1 plus VV by VS. Let's go into the volume relation. VV by VS, that is very important, that is void ratio. Okay, so this is coming as E. So gamma D can be expressed by gamma W times G is divided by 1 plus E by this formula. Okay, so you can derive many more terms which are here in, let's say, bulk density, gamma bulk. You can also derive this gamma bulk instead of by this relation. You can derive like this type of relations. Okay, so that's all for this phase relation of soil. In the next video, we'll discuss about soil classification, then how soil clay minerals are formed, then permeability, then seepage, and like that, with the shear strength of soil and compaction of soils, we'll complete this soil mechanics. Okay.